Question number 6. Let a1 is less than b1 and a1 is greater than 0 for n greater than or equal to 1. Define an plus 1 is equal to square root of an into bn, and bn plus 1 is equal to an plus bn divided by 2. Then which of the following is not true? Be careful here, is not true, which is usually a question will be asked, which one of the following is true? Here, which is not true. And now we have to answer carefully here. The solution for this, given 1, 0 is less than a1 is less than b1, and 2, an plus 1 is equal to square root of an into bn, and bn plus 1 is equal to an plus bn by 2. We will show here an is increasing sequence, two, bn is decreasing sequence, and third one, both an and bn converge to the same limit. Clearly, b2 is equal to 1 by a2, b2 equal to a1 plus b1 by 2. It is greater than square root of a1 into b1 is equal to a2. By the given condition, we can see here why this is a1 plus b1 divided by 2 is greater than root of square root of this one, because arithmetic mean is greater than geometric mean, and therefore now let us assume bk is greater than ak for some fixed k, then bk plus 1 is equal to ak plus bk by 2 is greater than square root of ak into bk equal to ak plus 1, and therefore the result is true for k plus 1 also, and hence this implies bn is bn plus 1 is greater than bk plus 1 is greater than ak plus 1, and hence by induction bn is greater than an for every n belonging to n, or n greater than or equal to 1. You can write down for n greater than or equal to, and let me call this as result 1, and also bn plus 1 is equal to 1 by 2 an plus bn and less than 1 by 2 square root of an into bn, b1 plus 1 by 2 into bn plus bn, because an is less than bn by 1, and that equal to 1 by 2 into 2bn, and that equal to bn. What we have obtained, bn plus 1 is less than bn for every n greater than or equal to 2. Therefore, bn plus 1 is less than bn for every n greater than or equal to 2. This implies bn is decreasing sequence. And let me call this is 2. And further, also an plus 1 is equal to square root of an into bn is greater than root of an into an, because bn is greater than an. We have proved, bn is greater than an. and this is equal to square root of an square is equal to an itself, and this shows that an plus 1 is greater than an for every n greater than or equal to 2, and this implies an is increasing sequence. Let me call it as a 3, and now therefore from 1, 2 and 3 it is clear that Bn is decreasing sequence which is bounded below and An is increasing sequence bounded above. By the result above, earlier we know that the sequence Bn is a decreasing sequence and bounded below is a convergent, and the sequence An is increasing sequence and bounded above is also convergent, and therefore both An and Bn converge to converge. Now, whether they are converging the same limit or not, let us say, let limit of An as n tends to infinity is equal to m, and limit of Bn as n tends to infinity is L. As Bn plus 1 is equal to half into An plus Bn, and therefore taking the limit on both sides, we get L equal to half L plus m, and this implies 2L equal to L plus M, and this implies L equal to M, and hence AN and BN converge to the same limit. Now we can choose this answer here. Which one is not true? And both AN and BN converge, but the limits are equal. This is true, but we have to choose the not true statement. Not true statement. A decreasing sequence, this is a increasing sequence, and therefore AN and BN converge, but the limits are different. This is not true because limits are same, we have proved. This is not true, and hence this is the choice for our answer. Limits are different is not equal or not true. So our answer is A only, converts to different limit, but their limits are same, equal, and therefore our answer is this. Question number 8. Let An equal to Bn plus 1 divided by Bn, where B1 equal to B2 is equal to 1 and Bn plus 2 is equal to Bn plus 1 for every n belonging to n. Then the limit of An is one among these four values A, B, C. Which one is correct? We have to check here. The solution for this is given An equal to Bn plus 1 by Bn for every and B1 equal to B2 is equal to 1 and Bn plus 2 equal to Bn plus 1 plus Bn for every n belonging to n. Now clearly Bn is Fibonacci sequence. That is 1, 1, 2, 3, 5, 8, so on so forth. You can get the value of Bn for any n here. With the initial condition B1 is equal to B2 is equal to 1. And also Bn is greater than 0 for every n. Now Bn plus 2 divided by Bn plus 1 equal to, I am dividing this one by this one. So I can write down this 1 plus uh, 1 plus bn divided by bn plus 1, and let me call this is equation 1, and also let me let x equal to limit of an as n tends to infinity. We know that limit of an as n tends to infinity is the same as limit of an plus 1 divided by, as n tends to infinity. But an plus 1 is equal to limit of, wherever n is there, you replace n plus 1, that is going to be bn plus 2 by bn plus 1, because an plus 2 is equal to this one, because an is equal to that quantity as n tends to infinity. By 1, we can write down limit of 1 plus bn by bn plus 1 as n tends to infinity. That is going to be 1 plus 1 by x. Therefore, this implies x is equal to 1 plus 1 by x, and that implies x square is equal to x plus 1, that is x square minus x minus 1 equal to 0, a quadratic equation, and therefore x is equal to 1 plus or minus root of 1 plus 4 by 2. That is 1 plus or minus root 5 by 2. Now here 1 minus root 5 by 2, 1 minus root 3 by 2, 1 minus 1 plus root 5 by 2. Here x must be 1 plus root 5 by 2, because the series is a positive term only. And therefore there is no negative value for the limit, and hence the result D is true, not 1, C, not B, not A. Question number 9, which states that let A1 equal to B1 is equal to 0, and for each n greater than or equal to 2, let an and bn be the real numbers given by an equal to summation from m equal to 2 to n minus 1 raised to m into m divided by log of m raised to m, and bn is equal to summation from m equal to 1 to n 1 by log of m raised to m. Then which one of the following is true about the sequence an and bn? This question has been asked in IIT-JAM 2019 examination. Four choices are given. Both an and bn are divergent. An is convergent and bn is divergent. An is convergent and bn is convergent. D. Both an and bn are convergent. Now we have to select or choose a right question here. The solution for this here an equal to summation of minus 1 raised to m into m divided by log of m raised to m is equal to 1 to n. Clearly, an is a sequence of partial sum of the series n equal to 1 to infinity, where an equal to minus 1 raised to n into n divided by log of n raised to n. And now limit of an raised to 1 by n as n tends to infinity equal to limit of minus 1 raised to n into n divided by log of n raised to n raised to 1 by n as n tends to infinity, that equal to what is that modulus minus 1 raised to n is getting out cancelled, and that equal to limit of n raised to 1 by n divided by modulus of log n as n tends to infinity. And as n tends to infinity, in the denominator modulus of log n positive number, and that equal to 0 less than 1, and therefore by Cauchy root test, the series minus 1 raised to n into n divided by log of n raised to n equal to 1 to infinity is convergent. Hence, the sequence AN is convergent. Now we will look into sequence BN. Again, similarly, the sequence BN is a sequence of partial sum of the series Bn n equal to 1 to infinity, where Bn equal to 1 by log of n raised to n. Now again, limit of Bn modulus of Bn raised to 1 by n as n tends to infinity equal to limit of modulus of 1 by log n raised to n raised to 1 by n as n tends to infinity equal to limit of 1 by log n as n tends to infinity is equal to 0, which is less than 1. Again by Cauchy root test, again by Cauchy root test, the series one by log n raised to n as n equal to 1 to infinity is convergent. And hence the sequence Bn is convergent. And now we can look at the choices given in the statement of the problem. Both An and Bn are divergent. An is convergent and Bn is divergent. An is convergent and Bn is convergent. It must be divergent and convergent. This is divergent dgt, and both An and Bn are convergent. This is true, this is wrong, this is wrong, and this is wrong. And therefore, option D is correct. Question number 10. which states that let A and be a sequence of positive real numbers. The series n from 1 to infinity converges if the series four choices are given. The choice A, summation of an square from 1 to infinity converges, and an by 2 raised to n from 1 to n infinity converges, and uh, summation an plus 1 by an converges, and also the last one, this is D, last one, an by an plus 1 converges. C and D are reciprocal to each other now. If you consider D, then automatically C will follow, or if you consider C, then D will follow now. Now we can solve this example solution. For option A, let me consider. For option A. Now let an equal to 1 by 1. 1 by n. Let us choose the nth term of the sequence. Then summation an n from 1 to infinity is equal to summation 1 by n as n tends to infinity. Sorry, n equal to 1 to n is equal to 1 to infinity diverges. It is very clear from the p-test. 1 by n raised to lambda is lambda is greater than 1, it is converges. Lambda is equal to 1, it is a divergent series. Whereas summation an square n from 1 to infinity equal to summation 1 by n square from 1 to infinity is convergent. Again, by the same lambda test, because here lambda is equal to 2, which is greater than 1, and this I can write down p-test, which say p-test, or lambda test, who can say. Now, though the an square converges, but the series an is a divergent series, and therefore option A is incorrect. Now we can look at option B. For option B, let an equal to 1, then summation of an n tends n equal to 1 to infinity equal to summation of 1 n equal to 1 to infinity. The sum of ones up to infinity is clearly divergent series. But but uh, summation of an divided by 2 raised to n equal to 1 to infinity equal to summation of 1 by, because an equal to 1 which you have assumed, 2 raised to n, 2 raised to n from n equal to 1 to infinity is convergent series. Why it is convergent? Because it is geometric series. This infinite geometric series with common ratio 1 by 2, which is less than 1. But however, summation of an is divergent, and therefore uh, the series an by 2 raised to n need not imply the series an is convergent, and therefore option B is also B is incorrect. Now we can consider either C or D. For the sake of convenience, I am considering the option D. For option D, let an equal to 2 raised to n square, 2 raised to n square, then summation of an by an plus 1 n from 1 to infinity equal to summation of 2 raised to n square divided by 2 raised to n plus 1 whole square, that is an plus 1, n is equal to 1 to infinity, that equal to summation 1 by, can calculate this one, that is 2 into 2 raised to 2n, n from 1 to infinity. 1 by 2 raised to this one, 2 raised to 1, which is infinite geometric series. Series with common ratio 1 by 2 less than 1, and therefore implies the series an by an plus 1 from 1 to n is equal to 1 to infinity is convergent. Though this is a divergent series, though the sorry, but summation of n equal to 1 to infinity equal to summation of 2 raised to n square n from 1 to infinity is divergent series. This condition D need not imply the convergence of the series an, and therefore now we have discarded all the other option, and therefore option C is correct. Therefore all options A, B and D are discarded. Hence option C is correct. Now you can see here option C is correct. Sorry. Option C is correct. This is not true. This is not true. And this is not true. And hence C is correct option. Now the question number 11. Let an be the sequence of real numbers such that a1 equal to 1 and an plus 1 is equal to an plus an square for every n greater than then. Which one of the following four choices is correct? And this is a MSQ question. Which of them? Maybe 1 or maybe 2 or maybe 3 or maybe 4 or all of them maybe 2. So we have to select the options which are correct. Now you can see here solution for this. Given a1 equal to 1 and an plus 1 equal to an plus an square for every n greater than or equal to 1. Now we have to see about a4. Now a2 equal to a1 means is equal to 1, 1 plus 1 square, that is 2 only, and a3 is equal to a2 plus a2 square. a2 is a 2, 2 plus 2 square, that is 6, and a4 is equal to a3 plus a3 square. a3 is 6, 6 plus 6 square means 36 plus 6, 42. Okay, now a4 equal to a1 into 1 plus a1 into 1 plus a2 into 1 plus a3. a1 is equal to 1, and 1 plus a1 means 2 plus 1, that is 1 plus 1 into 1 plus 2 into 1 plus 6, and that equal to what is that, 2 into 3 into 7 is equal to 42, and therefore this is a4, and hence A is correct one choice. Next we have to see here, we know that it is given that an plus 1 is equal to an plus an square. Okay, and this is greater than or equal to an, because an square is positive, it is positive, and therefore it is greater than this one. This implies an plus 1 is greater than or equal to an for every n greater than or equal to 1, and this implies an is monotonically increasing one. Increasing sequence. Now, limit of an plus 1 by an as n tends to infinity equal to limit of an plus 1 divided by an equal to the limit of 1 plus an square as n tends to infinity, because an plus 1 is equal to an plus an square dividing by an divided by an divided by an an uh, that equal to 1 plus an, not an square, an, and this is greater than 1 because an is greater than or equal to 0 for every n. And this implies by ratio test limit of an as n greater than or equal to n is tending to infinity is equal to infinity. I mean divergent is divergent. An is divergent. And sorry, an is divergent. Therefore, limit of an as n tends to infinity is equal to infinity only because it is a divergent. Therefore, limit of 1 by an as n tends to infinity is equal to 0, and therefore option C is 0. Therefore, option 1 by an, option B is correct. And hence option A and option B are correct, and this C and D are not correct. Solution for this. Now here consider an equal to n plus 2 by n raised to n square. We know that the radius of convergence is defined if r is radius of convergence, radius of convergence of the series convergence, then it is defined in terms of reciprocal of r, that is 1 by r equal to limit of modulus of an raised to 1 by n as n tends to infinity. And here we can see here limit of modulus of n plus 2 by n whole square raised to 1 by n as n tends to infinity equal to limit of n square, this is n square, limit of n plus 2 by n raised to n as n tends to infinity. Now here n square is there, 1 by n is there, so it is left out the power as n only, and that equal to limit of 1 plus 2 by n raised to n as n tends to infinity equal to e square, because limit of 1 plus x by n or a by n raised to n as n tends to infinity equal to e raised to a, not this, equal to e raised to a. And therefore r equal to radius of convergence, radius of convergence equal to 1 by r, that is r equal to 1 by e square, 1 by e square. Therefore option D is correct. Not this, not this, not this. Question number 13. Let a equal to limit of 1 by n square plus 1 by 2 by n square, etc., etc. I'm sorry, here etc. n minus 1 by n square, and b is equal to limit of this 1 by n, 1 by n plus 1, 1 by n plus 2, etc., etc., 1 by n plus n. Which one of the following are true? This is MSQ question. Appeared in 2020 on IIT-JAM examination, and four statements are given. Among these four, which two or three or all of them are true? More than one, of course, certainly, and because it is a MSQ question, and the solution for this. Now we can consider a equal to limit of 1 by n square, 1 by n square plus 1 by 2 by n square plus etc. plus n minus 1 by n square as n tends to infinity, which I can write down as limit of 1 by n into 1 by n plus 2 by n plus etc. plus n minus 1 by n as n tends to infinity equal to, I can write down this as limit of 1 by n into summation 1 by 1 plus r by n from n equal to 1 to n as n tends to infinity, and that equal to integration of 0 to 1 1 by 1 plus x dx. This is I am using a Riemann sum. That is integration of summation of 1 by n f of r by n r equal to 1 to infinity is equal to summation of 0 to integration of 0 to 1 f of x dx. This we have used twice in earlier case, and that equal to sorry, not 1 by x only, because x dx, and that equal to, as you know, x square by 2 from 0 to 1, and this is equal to, you know, x square by 1 means 1 by 2 minus 0 equal to 1 by 2 equal to 0.5. This is the value of A. And now we can see about the value of B. Next, B equal to limit of 1 by n plus 1 plus 1 by n plus 2 plus etc. plus 1 by n plus n as n tends to infinity equal to, again I am using the same technique, that is 1 by n into 1 by 1 plus 1 by n plus 1 by 1 plus 2 by n plus so on and so forth plus 1 by 1 plus n by n. I can write down this way as n tends to infinity, and this is nothing but limit of 1 by n summation of 1 by 1 plus r by n, r equal to 1 to n, and n tends to infinity, and that equal to, again by Riemann sum result, 1 by 1 plus x dx, and that is going to be log of 1 plus x from 0 to 1, and that is equal to log 2 base A. This is the value by the formula, and this is the value. Now, therefore, clearly from the value of A and B, therefore, clearly A is less than B and AB we have to search because this option is also given is equal to 1 by 2 log 2 is equal to log root 2 and A by B equal to 1 by log of 2 log 2 is equal to 1 by log 4. And from these values, and therefore options B and options C are correct. And hence option B is correct. Option B is correct. And also option C is correct. Not this and not this. And hence the result.